So now that we know how to take the probability of a single event, we're also going to look at finding the probability of multiple, disjoint, and non-disjoint events occurring. So what we want to know first is what is a disjoint event. A disjoint, or it's also called mutually exclusive event, are two events that have no common outcomes. So there are no possible outcomes in common for these events. Now, we have two identities that we need to know here. If our two outcomes are called A and B, and we are looking for the probability of A and B occurring, we take the probability of A and multiply it by the probability of B. So this is A and B, we multiply. If you are looking for either the probability of A or B occurring, so we don't care if A or B occurs, then you take the probability of A and add it to the probability of B. When we add, we don't care which one happens. When we're multiplying them, we want A and B both to be happening at the same time. So looking at example 1, my situation is that I have a bag that contains 6 white, 3 blue, and 7 green marbles. 6 white, 3 blue, and 7 green marbles. If 2 marbles are chosen at random, what is the probability of each event? So we have total 6 plus 3 plus 7 marbles, which gives me a total of 16 marbles. And I want to know what the probability is that both marbles we choose are white. So we want, we're looking in this case for the probability of A being white and the probability of B being white. So we're going to multiply both of these. So the probability of our first one being white, there are 6 white in there, so that is 6 over 16. Now, I have already taken out 1 white marble from the whole thing. So I only have 15 marbles left, and only 5 of them are going to be white. So the probability of my second marble also being white is going to be 5, because there's only 5 white marbles left, over 15, because there's only 15 marbles left. So when I multiply those together, before I do, let's reduce as much as we can. 5 goes into 5 once, and 5 goes into 15 3 times. And 6 over 16 reduces by 2. 2 goes into 6 3 times, and 2 goes into 16 8 times. So when I multiply that across, I have 3 over 8 times 3, which is 24. But that also reduces one more time. 3 goes into 3 once, and 3 goes into 24 8 times. So the probability that both of my marbles come out white is 1/8. So let's do the same thing for part B. I'm looking for the probability that both marbles are green. So I want both of them to be green, so this is an AND situation again. So I'm going to multiply. The probability of the first one coming out green is 7 over 16 times. Now, I've already pulled out a green marble, so there's only 6 green marbles left, and only 15 total marbles left. So I have 7 over 16 times 6 over 15, so we can reduce these as much as possible. We have 3 goes into 6 2 times, and 3 goes into 15 5 times. But then I also notice that I have 2 and 16, which reduce here. 2 goes into 2 once, and 2 goes into 16 8 times. So that's going to make my multiplication a little bit easier. 7 times 1 gives me 7 on top, and 8 times 5, 40 on bottom. So my probability of pulling 2 green marbles is 7 over 40. Example 2, my situation is that I have a card drawn from an ordinary deck of cards, which means there's 52 cards total. Okay, a regular deck of cards has 52 cards. And I want to know what the probability of getting a jack or a 6 of clubs is. So I am pulling only one card here, but I want a jack or a 6 of clubs. So I'm actually going to be adding these two probabilities. Now the probability of getting a jack, there are 4 jacks in a deck, so it's going to be 4 over 52, plus, now it doesn't say that we're drawing 2 cards, we're only drawing 1 single card. So my second probability is the probability of specifically getting the 6 of clubs, which is 1 out of 52. So when I add those together, I already have common denominators, so that's going to give me 5 out of 52 as my probability of getting either a jack or a 6 of clubs. Part B, the probability of getting a diamond or a club, we're going to be adding again. The probability of getting a diamond. Now, in the previous lesson, we counted up all of the different numbers of cards per suit, and there are 13 cards in each suit. So the probability of getting a diamond is 13 over 52, plus the probability of getting a club. There are also 13 clubs in the deck over 52. So that gives me a probability of 26 over 52. 26 over 52 reduces to 1/2, which makes sense because we're looking for either one or the other of each of the suits. So we're wanting to get 2 out of the 4 suits. So our answer will be 1/2. Example 3 gives us this situation. Sonia is moving and all of her CDs are mixed up in a box. 12 are rock, 8 are jazz, and 5 are classical. So I'm going to rewrite that as rock, there's 12, jazz, we have 8, and classical, we have 5. So that gives me first a total of 8 plus 5 plus 12 gives me a total of 25 CDs. Okay. She reaches in the box and selects 3 at random. Find each probability. So we're actually selecting 3 different CDs here. And I want to know what the probability of all jazz is going to be. So she has 8 jazz albums. So the probability of pulling the first one jazz is 8 over 25. Now we want all of them to be this certain probability. So that means we're going to multiply. This is an AND situation. The first album is jazz, and the second album is jazz, and the third album is jazz. So we're multiplying here. Now I took 1 CD away, and one of them was jazz, so that means my probability for my second is going to be 7, because there's only 7 jazz CDs left, over 24, because there's only 4 CDs left, times, and remember we're pulling 3 here, so my last probability of pulling the last one jazz is going to be 6, because there's only 6 jazz albums left, over 23, because now I've had already chosen 2. So let's see if we can reduce anything first. 8 goes into 8 once, and 8 goes into 24 3 times. And then I notice that I have a 3 and a 6 here. So 3 goes into 3 once, and 3 goes into 6 twice. So on top, if I'm multiplying just straight across, I have 7 times 2, which gives me 14. And 25 times 23, which after we do all of that work gives me 575. So the probability of me pulling 3 jazz albums out of that box is 14 out of 575. Not great odds. So let's look at probability of all of them being rock. The probability of the first one album being pulled as being rock is 12 over 25 times, we'd already pulled 1 rock album out, so times 11 over, now it's only 24 albums left, times, now we only have 10 rock left and 23 total. So we have 12 over 25 times 11 over 24 times 10 over 23, and a lot is going to reduce here. 25 and 10 both reduce by 5. 5 goes into 10 twice, and 5 goes into 25 5 times. 12 and 24 definitely reduce. 12 goes into 12 once, and 12 goes into 24 2 times. And then I have a 2 and a 2 here, so those are going to cancel out completely. So on top, I am just left with 1 times 11. And on bottom, I'm left with 5 times 23. So my odds are 11 out of 115. A little bit better pulling all rock albums than pulling all jazz. So when we're looking at the probability of two specific things happening at the same time, A and B, we need to make sure that we multiply those two probabilities together. But when we don't care if A or B happens, we take each probability and add them. So if we are looking for two things and both of them occurring, we multiply. Only one of the things has to happen, we add them both together.